Okay, welcome everybody. Welcome to the CIRA Streams project. Thank you for coming along. This project is all about streaming video, so we're streaming today's event, both the video and audio, to some remote participants across the internet. Before I go further, I'll introduce myself. I'm Gori Fairhurst. I'm a professor here in the School of Engineering, and I'm the principal investigator for the CIRA Streams project. Tonight, we're introducing an event that was conducted at the Scottish Sculpture Workshop. The event was all about smelting Iron Age iron, which you'll find more of as we go through the evening. But before this talk, I'd just like to introduce a little bit of the technology. We have in .rural a large investment by RCUK, where we're exploring the use of digital technologies. We're looking at a wide range of research projects, exploring how they interact with rural communities and with local businesses. In the CIRA project, one of the projects funded by .rural, we are looking at, that's me on the picture, yeah, okay. Thank you. We're looking at how we can use broadband technologies. So we're looking at internet video, we're looking at satellite communications and rural broadband as a means to engage with communities who are from the creative sector. So letting people work creatively with other people in other rural areas. In particular, we're looking at the value of streaming and its impact on the cultural activities. Later on, we'll be asking questions, and we'd like you to fill in our questionnaire. Before you get there, you have the opportunity to ask questions, and each of our video clips will be followed by a question and answer session. Please feel free to ask any questions. We'll be also trying to collect questions from our remote participants. Before I say anything else, I'd just like to give you a few health and safety notes. The staircase here shouldn't be used in the event of a fire. Please use this stair so that you don't trip over cables. There are no intentional fire alarms, so if you do hear a fire alarm, please leave the building. With that said, I'd like to introduce Nuno. He can tell us a little bit about the Scottish Sculpture Workshop and the Turf to Tools project, which stimulated the work that we're going to show later. So would you like to come and introduce yourself?
Hi there. Good evening. Can you hear me okay? Yeah, my name is Nuno Sacramento. I'm the director of Scottish Sculpture Workshop, which is an organization located in Lumsden, Aberdeenshire. SSW is 35 years old this year. It was set up in 1979 by the sculptor Fred Bush. As the name indicates, Scottish Sculpture Workshop is a place where sculptors come to from all over the world to develop projects, to develop their technical abilities, and to be in contact with other artists. We work from a very embedded perspective, so we're actually paying attention to what's around us. So we study and develop sculpture, but we're also very, very interested in the question of territory and land and landscape. Let me begin by saying that we're very happy to be collaborating with the University of Aberdeen and .rural in particular. As a rurally based location, we want to make the most out of the digital technologies, because in a village of 300 people, as you'll imagine, the footfall is very, very small. And we decided to embrace this capacity to, like what we're doing now, reach a much wider audience and use the network to do that. So this project from Turf to Tools that Eden is going to talk about in more depth is part of a series of projects that we call slow prototypes. And slow prototypes is obviously a wordplay on rapid prototyping. We wanted to slow the process down and bring the hand rather than the machine into the process. So we decided that we would set up a project that brings together contemporary artists, craftspeople, and a writer. So it becomes a kind of a triangle. And the idea was that the artist, who's usually the author and the person with the idea and the concept, in this case, must not ask the artisan or the craftsman to make something for them, so that we prevent the whole thing falling into the kind of default position of the artist being the brain and the artisan, the pair of hands. So we did 3 projects, slow prototypes, between 2012 and 2014, and decided it had still a little bit of money left, and decided to do a project with Eden Jolie, who, alongside being the technician at Scottish Sculpture Workshop, is also an artist with a practice. And it was about the opportunity for Eden to invite a craftsman of his choice to come and work with him. So Eden chose to work with Darrell Markewitz from Ontario in Canada, who's a very, very specialized in forge and in the kind of work that Eden's going to talk about. So Eden and Darrell's collaboration was also assisted by Dr. Gordon Noble, that works in this institution at the Department of Archaeology. He's developing, he's the main researcher in a dig in Rhynie. So he was instrumental in the development of the project, and so were Maxim Hourani from Lebanon and Deirdre O'Mahony from West Ireland. So during the month of August, we had a really hectic, amazing time at SSW's. Some of you guys were out there with us, and basically we're looking at this idea of sculpture craft in the landscape through the usually places like Scottish Sculpture Workshop. Their emphasis is on producing artworks from materials that are ordered, that are bought from a supplier, and we wanted to take this project further and look at the procurement of materials within the landscape. So where does this metal come from? So Eden's proposal was to look at bog iron ore procured in the landscape, and take that material through a smelting process, through a forge process, into the making of a tool. Anyway, Eden, Darrell, and Gordon were assisted by Thomas Stackhouse, Uist Corrigan, and James McCarthy. So I'm not going to take any more time, but I'd just like to thank you for being here. I thank the people, whoever is watching us from afar through the network, and pass on the word to Eden. Video.
I don't know who the patron god or who's in charge of this mess is here. Does that only happen when you try to put something down there? Yeah. Maybe I should just stand there. That's hilarious. We've got a clay furnace. It's already been used a couple of times. The clay is dry. And we did an experiment the other day with peat as a possible fuel. And as any of you who have burnt peat know, that stuff smolders forever. So we ended up leaving the peat in the furnace and capped it off with a metal plate. So we came out this morning, there was still smoldering peat in the bottom of that. The purpose of the preheat is to warm up the clay so that we're not wasting charcoal energy by warming up the furnace. All right? So what we've done is sort of a wood fire with some just wood splints, gentle air, and soon, excuse me, what we'll do is we'll add rough charcoal to fill that container, all right? And then make sure that's lit. Once we get the thing full of rough charcoal and it's burning in the bottom, you can see we're supplying air in the bottom of our furnace. We'll follow that up with charcoal that's been carefully sized. There's a relationship between the type of ore you use, how big the pieces of ore are, how big the furnace is, and how big the charcoal is. And maybe what type of trees you use for the charcoal. Nobody's looked at that yet. Okay, so we got an ideal size. We want our charcoal to be pieces from about a walnut down to maybe about the tip of your little finger, a pea. All right? So once all that thing has got charcoal in it and the whole thing gets hot, many of you use charcoal for barbecue, you know, you got to get the charcoal burning properly before you put your hamburgers on there. We got the same thing. We got to heat up all that charcoal. Then what we'll do is we'll start adding essentially handfuls of ore and handfuls of charcoal. And that process of adding bits and pieces will go on for about 4 hours. Okay? And if we do everything just right, we'll open up the bottom of the furnace probably about 4 o'clock, and we should get a mass of white hot iron out of the bottom of that. Now, for those of you that haven't listened to me talk about this over and over again, this is how they made iron here 1,000, 1,500 years ago. So this furnace is based on one from an archaeological dig just outside Inverness, dated about 200, 400 AD, kind of after the Romans left. Okay? So a lot of the work we're doing here is based on the local materials out in the hills and things we know from the archaeology of the ancient pits. All right? So, what do you think, Eden? Are we definitely going to start out the work here? Yeah, yeah. Now what we'll get here is it'll support the charcoal. Yeah. So, who's my charcoal man here? Is that Darrell? We're going to keep it our standard job. Okay, so rough, okay, to fill. Yeah. And we'll, you're going to have an airspace in the bottom because of the rough one. Keep track of your volume like normal, right? Yeah, okay. And fill it right up. Okay. Now, the furnace has to be a certain temperature to be operating correctly. How are we going to measure that? We're picks. We don't have fancy thermocouples, right? We could peek down there, and the brighter the fire is, the hotter it is, but that's a little hard to judge. What we're going to do is we're going to keep track of how long it takes to burn a bucket of charcoal, the same bucket of charcoal. And this bucket you can see James using will burn that much charcoal about every 8 minutes for 4 hours. Now, one of the things you're going to see when he adds this rough charcoal starts to heat up. It's got water in it. So there's going to be a lot of smoke. And there's also unburned chemicals in there, meaning methane. So we're going to get this for the first little bit. It's going to be really smoky. Once the furnace starts to ignite down inside there, what will happen is the methane, that secondary chemical, will suddenly catch fire. And all the smoke will disappear. And there's actually a pale blue flame coming out of the top of that. It's real hot. Okay, so we got to be kind of careful about that. Of course, this is not necessarily the best for the environment, right? We want to burn off those extra chemicals. Also, igniting that smoke on the top makes it really, really hot. So it goes straight up. I don't have to breathe it in. That makes me happy too. Now this will take a couple of minutes for you to be able to see this, but we've got a series of holes up the side of the furnace, and we call those light brights, and you will actually see the color change inside those holes as the flame moves up the column of charcoal and ignites it all. The reason we put those in actually is because we do have a thermocouple, and because this is also a bit of a scientific experiment, we'll be measuring the temperature down inside the furnace with that thermocouple. How's those gases being touched off? Okay, so this represents the start of our smelt. I've nudged the guys a couple of times about coming up with a starting ritual. Nobody's done it. Okay? It's Scotland. We got peat. All I'm going to ask is that everybody puts in a piece of peat on top of the fire. There's exactly. Think about the smelt now. We're into the smelt, okay? So no more goofing around. Everybody's centered in what they're doing, right? Everybody's head's in the smelt. Yes? Yes. Good. Okay.
At this stage, we'd like to invite Eden to tell us a little bit about what is going on and answer any questions that people might have. Eden's also brought along a large selection of interesting things here. Leon? Okay. Eden, do you want to start by just introducing yourself?
Hello, I'm Eden.
This is Eden.
So, any questions so far?
There was a huge noise on that video, and some sort of, I don't know what it was, machine getting
We were cheating. We were using a leaf blower for the air. We had built some bellows, but it was going to take one stroke of the bellow every second for 6 hours. And we thought that was a bit excessive to run the furnace doing that as well. And we didn't have enough volunteers to do it, so we used the leaf blower. It was an Iron Age leaf blower, though. So. Yeah. Jolly good. Is that me finished then?
So I guess a good prompt for you would be, why did you choose to bring Darrell in this project across?
I've done a lot of, as Nuno said, I'm a practicing artist as well as a technician, or mostly technician. A lot of my work is centered around the environment, the landscape, in particular land access. A lot of the landscape you're not allowed to access to. You've got grouse shooting, deer shooting, all that sort of stuff. It's owned by people. So I did a lot of little surreptitious gold casts about the landscape. I asked people about what they thought about the landscape and cast their text into gold and threw them away in the hills. So in the hills, there are little golden plaques with text on relating to the actual part of the landscape. And I took that further and did one in the city. I found an engraving of a bridge that's no longer there. This is in Newcastle. And I found roughly where the engraving was taken. It turned out to be somebody's back garden. So I put that onto a gold plaque and in the middle of the night jumped over the fence and buried it in their garden. So again, so it's about land use and access and sort of thing, how the landscape changes. The notes are down there. You take meticulous notes of the actual process. So you see how long it's taking for it to burn, how long between charges. If it slows down, that's the ore burning now. Yeah, we'll drop it. If it starts going really, really quickly, you need to shut down the air or increase the amount of ore that's going in. Anyway. So there's a lot of waiting around, a lot of standing around. What I'm doing there is having a look inside the furnace through the tuya. There goes some ore. When you look inside the furnace, you can actually see the metal pouring down, little drops of iron floating down. And when that does, it sits on a bowl of slag, which are all impurities, bits of lining, what have you. Here we go. Darrell's taking the front of the furnace off and exposing the bottom base of the furnace, which is like grounds of charcoal. And I think at this point he's checking the slag bowl. So I'm breaking the bottom out now.
Yeah, you see, you get a long way to feet up there. So you have to take up the drill, pull it this way, so that you're kind of making a dam, because if you suddenly get that feet itself, what's going to do?
So I don't know if you heard that. He's making a little dam with the charcoal flames on the base of the furnace. You know, it's going to just like try and tap the bottom of the slag bowl and release some of the slag. What that'll do is drop the actual gleam itself further down the furnace, the smelting side.
So, Dirk, you should actually be able to see the bottom of the bowl. I don't know, can you have the orange? No, it's further up. So it's sitting higher than it was last time. Which is odd because we made the base lower than we did the first time around. Okay, you got most of it out? Now, it doesn't have to be totally clean. So use the tip of the tool and feel up and figure out where that bowl is. If you take it, okay, rotate it that way, you should be able to lift up and kind of see where the bowl is. You feel it? Yeah, yeah. Okay, so that's the bottom of your slag bowl. So that's the space we got to work in. There's a difference between that hard flat bottom and the bottom of that bowl, right? About that much, right? Yeah? Okay. Okay. So what we want to try to do is we want to try to let some of that liquid slide out. Okay? This does get a little different. If you get right down, you can see the bottom of the
Well, rather than what he's going to do is try and punch a hole through the slag bowl. Okay, you'll just watch it in front.
Okay? So do that same thing. Find a spot, okay, and then just kind of tap it up in the diagonal around it. Okay? There we go. Hopefully this is going to get easy. Okay, cut one of it. Right here. You can get in one too. Now let's try a couple of spots. How we doing? We're good there? That's not down the piece, that's fine. No joy still.
Say it's not dropping fast.
How's that?
Starting to real drop fast, real fast.
I don't want to break it up. I don't want to end up in
Got some slack coming out there.
It's funny because I'm really Hopefully what you have is money,
escape from the side of the furnace there. It's oozing out. It's fine. It just chills and blocks itself up. But yeah, it's quite exciting when it happened the first time. So we put that back up again now. If you do come down there, you can have a look at it. This slab is bloom producing this smell. It's the other top of this fruit. It's the air flow on the top and the base is blooming. The metal, that's how it starts to metal stuff. Really, this is the extraction. Fire can crush.
Okay, so I'm doing the box.
So Darrell's just trying to loosen the actual bloom from the side of the furnace just by moving it up and down. And there it is. Stop.
Right? Okay, so yeah, feels like it's loose. Right?
It's quite large. It is surrounded by slag, so
Now the trick is when we get it out of that hole.
as part of this experiment we put in burnt bone in the top as well. At this stage, that is the hottest it's going to be. And you can see why the furnace is in sections now. We weren't quite expecting it to be so large. So what we need to do now is as quickly as possible get it onto the anvil and break as much of the slag away while the metal's still super hot. Traditional process would be done on either on a wooden stump. Here we go. See, it's pretty heavy. It's pretty hot. We've got every smelt furnace up to 1370 at the front. So that's just knocking the slag off the bloom now. There's some bits of the slag melting there a little bit later.
It's okay. I got it done. So, yeah, if you get, no bother hanging on to it. Turn, don't worry about it. Stop. Hopefully most of that should work out though.
There's plenty of it. Yeah, the raw loincloths. So you see already how much it's reduced in size from what it was then. There is actually a fair bit of metal in that slag around the edge. So we would go through that and pick through that. And possibly use it a bit of damage it makes.
Hey, will you quit hitting me in the garage with that stuff?
Obviously it's cooling down all the time as well, so we go as far as we could, then we transfer it to a furnace for basically forge furnace.
Everybody's a bit tired.
That was quite large, I couldn't really fit in our forge. So we're going to try and heat it back up again now in the furnace.
I can't pick it up, it's too heavy. Take it from the side, come in this way.
What we're trying to do there is get it to welding temperature, forge welding temperature, and that, as we hit it, the slag, all the other impurities get flung out of the metal as it's squeezed together.
Oh no! Look at the aluminium tape! Circle. Give me two.
Yeah, and one of Gordon's archaeologists, Emma, she was researching into Icelandic smelting, and they found evidence of charred bone in amongst the metal amongst the furnace. So, oh, here's Darrell. So we were putting that in the top there. Anyway, Darrell.
Can you hear us, Darrell?
Yes, sir. Circle. Give me two. Yeah, okay. Bear in mind there's a 30-second delay.
When you bashed out the bottom of the furnace, I was expecting it all to come streaming out as a liquid. Is that not what happens, or does it? Would it be possible to get it that hot, or? It's just not what I expected. That's all.
Okay, there's two things going on there. There's a liquid slag that collects in the bottom of the furnace. It's made up of sand and furnace wall and ash from the charcoal, and is a very primitive kind of glass. It is heavier than the charcoal, so it runs down to the bottom part of the furnace. The base of the furnace is cold, so that glass freezes and creates a bowl. So imagine a soup bowl in there that contains some of this liquid glass. And the bloom that you saw that we pulled out is surrounded by that liquid glass. So that if you get too much of that slag accumulated, you're absolutely right. You would actually have to pour that off as a liquid to keep it from drowning the airflow. I'm not sure how well it showed up in the video, but there would have been a quantity of liquid that would have been let free of the base of the furnace when we grabbed the bloom out. If you think back to the image you saw, the camera sees further down into the infrared than your eye does. So the bright yellow in that bloom mass would have been the metal, whereas the darker red, and particularly the gray colored stuff, is essentially some of that frozen glass. And we would have been squirting out little bits of glass as we hammered on it. Go. Is surrounded by that liquid glass.
Okay. Any other questions for Darrell or Eden?
You're absolutely right.
You gonna talk?
Hi, Darrell. Eden here. I think what Jake was asking is why we ended up with a bloom rather than molten metal.
I think at one point, Eden, you had commented about the production of cast iron. Cast iron has a higher carbon content than a metallic iron does. And the objective of an ancient style bloomery furnace is to make as low a carbon iron as possible, because that's easiest for the blacksmith to physically hammer. If we let our furnace run too hot, which, as I said in the beginning, is controlled by looking at how fast we're consuming a fixed measure of charcoal. If it runs too hot, the conditions inside the furnace will cause the metallic iron to absorb excess carbon from the charcoal. And we will, in fact, get a cast iron. But in these ancient furnaces, that's not desirable. So we were actually controlling that temperature we were producing by taking into account how fast we were burning that charcoal. Cast iron has a higher carbon content.
The first smelt I did before Darrell came, I actually managed to make cast iron. So because I've had a lot of experience with cast iron furnaces, making cast iron, I ran the smelter as an iron furnace and managed to produce cast iron accidentally.
One of the changes that happens into the medieval period is that if you actually use a big water wheel to power your bellows, you have more air, which means you can create a higher temperature. And the default then is to make a cast iron. And during the medieval period, what they would actually do is they would make this cast iron product, which was easier to control, and then they would put it into a second fire setup called a finery and decarbonize it to remove that excess carbon and create a metal then that they could hammer in a blacksmith's forge.
Manu?
Hi, that's very interesting. I've never seen anything like it before, so thank you. I was wondering, there was very meticulous keeping of the times, but wouldn't it make sense to also have samples of the raw materials, such as, I don't know, is every bit of charcoal the same as every other bit of charcoal? And does the weather matter? I don't know, do these parameters have an impact on the process?
I didn't catch all of that. You were asking about different kinds of charcoal creating different effects?
Are there variations in that, and the weather, does that impact the process? Does the smith need to take that into account?
So first of all, charcoal. The historic pattern is that ancient furnaces were located where the ore was. And the archaeology seems to indicate that they would use whatever charcoal was available. You look at the pollen counts in the archaeology, it's identical to the charcoal species. So they just use the trees that are close. There is a structural component difference between using a softwood and a hardwood. Different regional traditions will use different materials. In Japan, for example, iron smelting is done with pine, whereas certainly here in North America, my preferred fuel is to use oak. In terms of weather, the water content of the entry air might play a big role. I have actually successfully smelted iron at 20 below 0 Fahrenheit, and also in the tail end of a hurricane working outside. And the water in the air actually made more of a difference than the ambient air temperature. The temperatures your furnace is running at are in the neighborhood of 1150, 1200 degrees Celsius. So you change the entry air temperature by 20 degrees C, it really isn't important from a percentage point of view. Here in North America, my preferred fuel is to use oak.
Any more questions for Darrell?
The water content of the entry air might play a big role.
How would you then turn the iron into steel?
Okay. Steel is a bit of a problematic term because a blacksmith, a metallurgist, and an archaeologist will use the same word to mean three different things. Historically, two things would happen. The iron master can tell by the texture and the color of the iron he makes its relative carbon content. So there could be a selection process made as soon as the bloom was starting to be processed down. A second thing a blacksmith can do is he can take a piece of iron and hammer it quite thin, and then take a bunch of those pieces and put them in a sealed container like a ball of clay with powdered charcoal or burnt bone around it, and bake that. And if you heat that material up to a dull red and leave it like that for several hours, the carbon will be absorbed by the metal. The resulting material in either case is steel, which is an alloy of iron and carbon. That makes the material harder and then suitable for tool making. So there could be a selection process made as soon as the bloom was starting to be processed down.
David?
Hi, I was wondering, and you've kind of touched upon this a few times in the videos and some of the chat, but is there anything particular about the iron that's made around here as opposed to iron made elsewhere in terms of properties, so across the rest of Scotland, across the rest of the UK, around the world?
That's a very good observation, because the ore, depending on the type of ore you're using, may also have small trace amounts of other elements in it. And those small trace elements can quite profoundly affect the quality of the resulting metal. And two nice examples of that from Europe would be the Rhineland in Germany or the Sheffield area in the UK, both of which have literally ancient reputations for high quality material. Toledo in Spain, much the same. And it's partially because of the specific qualities of the ore available. Now, good quality ore, good material, would attract the best quality tradesmen. So not only do you have a better quality metal to start with, you have better blacksmiths, thus making much, much better objects, which is why we know those names as being areas of ancient high quality, particularly weapons production. It's theoretically possible for an archaeologist to analyze the trace elements in the iron of an artifact and then go back to the source ore to tell where that object was physically made. This is not often done because it is a destructive process outside of modern technology. An example would be at Lancemeadows, Newfoundland, where the Norse came in the year 1000. They smelted iron once, and they did compare a nail that was made at found at Lancemeadows with the ore that was used at Lancemeadows, and the two things match in terms of their elements. So they could tell that the metal from that nail was actually physically made in Newfoundland around the year 1000. PhD for somebody. It's theoretically possible for an archaeologist.
Any more questions at all? Okay, I think we might have reached the end of the questions, Darrell and Eden. So thank you very much for joining us. I think he's speaking, but we can't.
The amount of air you contribute to the fire changes the quality of the metal that's produced. And the type of drum bellows we were thinking about using creates a low volume of air, which gives a spongy bellows, a spongy bloom. You certainly get iron, but you don't get the super dense puck-style blooms that are typical of Pictish or Scandinavian iron processing from 1500 years ago. That suggests they may be doing something else to make higher volume of air. Yet another research project to undertake.
Okay, thank you very much, Darrell. That was fantastic. Thank you for joining us from all the way over there. Thank you, Darrell and Eden.